Hi everyone! Welcome to today's video. We are diving into a crucial topic for any STM32F4 project, designing a crystal oscillator circuit. This circuit is the heart of your microcontroller's timing. It provides the precise clock signal that the STM32F4 needs to run accurately and reliably. Without a stable oscillator, your MCU could behave unpredictably. Let's break down the key steps. First, you need to choose the right crystal. The crystal's frequency is your starting point. Common frequencies for STM32F4 MCUs include 8 MHz, 16 MHz, or 25 MHz. Check your specific STM32F4 datasheet for recommended frequencies. Another important specification is the crystal's equivalent series resistance, or ESR. A lower ESR is generally better for easier startup and stable oscillation. Also, pay close attention to the crystal's specified load capacitance, often written as CL. This value is critical for selecting the right external capacitors. Most MCUs use fundamental mode crystals, not overtone types, so ensure you pick the correct one. Next, you will select the two external load capacitors. These are typically C1 and C2. They connect from each crystal pin to ground. The total capacitance seen by the crystal must match its specified load capacitance, CL. The formula for this is approximately C_load equals C1 C2 / C1 plus C2 plus C_stray. C_stray accounts for parasitic capacitances from the PCB traces and MCU pins. For simplicity, C1 and C2 are usually chosen to be equal. For STM32F4, common values for C1 and C2 range from 10 pF to 22 pF. Always use high-quality ceramic capacitors. Specifically, MP0 or C0G dielectric types are best. They offer excellent temperature stability. This means their capacitance does not change much with temperature variations. Now, let's talk about PCB layout. This step is extremely important for a stable oscillator. Place the crystal and its two load capacitors as close as possible to the STM32F4's OSC_IN and OSC_out pins. Keep all traces connecting these components very short and direct. This minimizes unwanted inductance and capacitance. It also reduces noise pickup. Route a solid ground plane directly underneath the entire oscillator circuit. This provides a stable reference and shields the circuit from noise. Avoid routing any other signal traces directly under the crystal or its associated components. This prevents interference. Ensure your power supply to the STM32F4 is clean and stable. Good power supply decoupling capacitors near the MCU are absolutely essential. This helps to prevent noise from the power lines from affecting the sensitive oscillator circuit. Finally, testing and troubleshooting. After assembly, you can use an oscilloscope to check if the crystal is oscillating. Use a low capacitance probe for this. A standard probe can load the circuit too much and stop oscillation. If it's not working, carefully double-check everything. Verify your crystal part number and its specifications. Confirm the capacitor values are correct. Review your PCB layout for any issues. Also, make sure your STM32F4's RCC, reset and clock control registers are correctly configured in your firmware to enable the high-speed external, HSE, oscillator. A properly designed and laid out crystal oscillator ensures your STM32F4 runs with precision. It's a small circuit, but its impact on your project's reliability is immense. Thank you for watching this video. I hope this guide helps you design robust crystal oscillator circuits for your STM32F4 projects. If you found this information useful, please give it a thumbs up. Don't forget to subscribe for more electronics tutorials and tips. See you next time.